So, fun story. This video would have been out earlier, but when I went to upload it and start editing, there wasn't any sound. Somehow my microphone came unplugged, and I recorded everything without checking it, and no audio. So this week, we're talking about sequences and flow control, which makes sense since we didn't control our audio last time. So sequences and flow control. So both really useful tools that we can do and utilize in any programming languages. We're going to be talking about them in Python. How do we use them? How can we manipulate them? And how can we use them to build video games and other applications? So let's start out with sequences. What are sequences? What do you think sequences might mean? You've probably heard this term used before, and it's pretty much what you're thinking it is. It's a sequence of data contained in some type of container. We have multiple versions of them. We have strings. We've already been using strings. Those are actually a sequence. There's also tuples and ranges and lists. These are all different types of sequences. There's also dictionaries. All of them are slightly different, but they work very similarly. Now, there are two types of sequences that we have. We have immutable, in which that essentially means we can't change them, we can't modify them, they're kind of stuck the way they are. Immutable, you can change, we can add and subtract and remove and modify mutable sequences. So our immutable ones, the ones we can't change, those are tuples, the strings, and ranges. Those are kind of stuck the way they are. We can always add to the end of it and create a new version of the sequence, but we can't actually manipulate this data itself. And we have lists and dictionaries. In those, we can actually change around our values in place. We can actually add and subtract, insert, all that kind of fun stuff, and use those in different ways. So they're both useful, utilizing immutable and mutable. All of these different sequences, though, they kind of have one thing in common. Just so we can kind of identify them, they all have their own delimiter. Now, we've already know what the strings delimiter is. We can do the single quotes, we can do single double quotes, we can do triple quotes or triple double quotes, and we know we can create a string. What we can also do is create a tuple. We've kind of done tuples a little bit, but the tuple is the two parentheses and then a comma in the middle. If we just use regular parentheses, it just is a mathematical operator or a priority parentheses, but when we put that comma in that middle, that signifies that there's multiple elements inside of it and giving us a tuple. And similarly to a tuple, we have a list. These has those nice square brackets on the outside, and that will create you an empty list, and then it has commas to separate the values just like a tuple does. Lastly, we have a dictionary. This has those nice squiggly brackets on the outside, and this actually holds key value pairs. Instead of just a single data piece or an object or an element, this has key value pairs. So each element will have two pieces. It'll have whatever the index of it is, so like usually a name or an identifier, which is your key. Then it has the value comparison. So we do our squiggly brackets to open and close our dictionary, and then you have a key, which is some type of value. You have a colon, and then you have whatever your actual value is. Between your key values, you just put a comma, and then you can go on from there. But it's just a bigger list with key value pairs instead of individual elements. Now, if we want to index tuples, lists, strings, we can use actually it's very similar to actually looking at a list, but you use the variable name, and then you actually use the braces just like you would a list, and then put a number in there, and it'll actually allow you to access individual elements. You can also do a range of elements by using a number and then a colon and a number inside your braces and access a whole range. The really cool thing is if you use negative numbers, it actually counts from the back of your list, and if you use positive numbers, it counts from the front of your list. Just remember though, all lists or all indexing starts with 0. So 0 is actually your first element, and 1 would be your second element, and so on and so forth. So whenever we're counting, 0 is your first thing always. Now, like I said, dictionaries are slightly different. Instead of indexing by the number or the iteration through with a number, you actually access it through your key. So if your key is a name, you would just do your dictionary variable name, you would do your brace, and then you would do whatever string in there that you used as a key to find the data you're looking for. As you can probably already tell, this could be really useful in creating the full-on databases where you want to look up things specifically by a key value pair. Sometimes we got to make decisions when we're making applications. We got to figure out how to control our application or see if something actually happened. And so we have a lot of conditional operators on top of the mathematical operators we've already talked about, or the assignment operators we actually talked about. So we actually can compare seeing if two things are equal by using a double equal sign, and then there's a not equal sign with the exclamation point, and greater than, equal than, all those kind of different operators that compare we can actually use. These have a lesser precedence than our mathematical operators. These will actually happen last. We need to make sure we know which order operations those are in. We also have not, and or. Those are other ones that are keyword versions. They're also just comparison. What can we use these conditionals for? Well, there's a couple things. First of all, we can do if statement. We can really check if something is happening. We can check if something is true. We can check all these different conditions to make sure that we execute certain code when those conditions are met or not met. The if actually has a couple different parts though. It's not just if something's happening, do this. You can also do an else, which allows you to say, if this is happening, do this part. If it's not happening, essentially, if it's not true, go to your else section and execute this part of the code. Once you're done with your if-else block, though, it drops out and continues on with the code. Now, to identify that you're within the if block or you're in else block, you want to make sure your code's tabbed over, one tab. Now, if we want to go one step deeper, we have if, then we have an elif, which is essentially an else with a conditional. So you can do if, elif, and then a second conditional. So the if would have a conditional, elif has a conditional, and then you would end with an else. And if you do this, you can actually have multiple conditions to go through. So if in state 1, elif in state 2, elif in state 4, elif in state 80, and then you have an else. So you'd have a couple default states, or your else would be your default state, and then you have specific states for those different state numbers. These sequences are nice, and our conditionals are nice for if statements. We can actually utilize those to trigger different things if something's happening. What else we can do is there's these things called loops. So if we ever want something to repeat, that's what this can do. And if will only happen once in your line of code and drop through. So we need to know that. We need to recognize that if and else will drop through. But if we want something to repeat, we have to use a loop. And there's times you're going to want to repeat things, or you're going to want to iterate things. And we have two main loop types to actually do those two steps. We have a while loop, which takes a conditional, and as long as that conditional holds true, the code underneath that's tabbed into the scope will actually repeat over and over and over and over and over until that condition is false, or we make some exceptions. Secondarily, we have a for loop, which is actually gives an iteration. So you tell it an iterator, and then that iteration, it'll count through. So we can iterate through our sequences or our lists and go through each element until it's empty, or until we're out of elements, until we hit the last element, and then it will drop out. So one will have to actually have a condition. One will go through a certain amount of data or a certain range before it falls through. It only repeats a certain amount of times because it has to link up with that iteration. What if we wanted to get out early? What if we wanted to get out of our while loop early and not wait for that conditional to happen? Well, there's this magic keyword called break. It actually breaks you out of the immediate loop you're in and gets you completely out and lets you drop through. Similar to how you drop straight through an if statement, a break will just drop through and then start the code that's outside of the scope of your loop. This can be used in whiles or fors, either one, but it breaks out of that immediate loop. Now, if there's ever a time we want to not necessarily break out of our loop and just end the loop altogether, but we want to continue to the next iteration or the next step in our loop, you can actually use the keyword continue. Now what that does is, instead of dropping straight out of your loop and getting rid of it, it actually skips over the rest of the current loop, wherever that continue phrase is or the keyword is, and it continues from the next iteration of that loop. So it can be worked in a while loop or in a for loop, either one. So why are loops and sequences being taught together? Well, like we said, for loops are for iterating, so get through something. You can use while loops to iterate as well, but your conditional essentially has to compare to whatever iterator you're utilizing. So they can be utilized similarly, but a for loop will actually step through automatically when you're using your end keyword, step through your iteration or your sequence until it gets through every element in your sequence, and then you can drop out. The combination of these things with if blocks and for loops, we can actually use them in cohesion. We can actually put them together and create really complex scenarios or complex flow control for our game. You can have a while loop that has multiple if blocks in it, and this is often how you would do some type of states in your game. You would have a while loop for the game actually running itself, and then you'd have, if this is happening, you should be loading this part of the game, or if this is happening, you should be showing this menu, or if this is happening, your enemy should be doing something. So those usually happen inside of the loop, those if blocks. In contrast to other programming languages, Python doesn't have local variables inside or local assignment inside of while or if or else statements or for statements. Anything you assign inside of a that scope essentially belongs to its parent scope. There's no local variable in there or local scope within those blocks. Most other languages would have a local scope, and what I mean by local scope is it belongs only to that scope, that tabbed section. Python doesn't do that, but many other languages would. So if you assigned a variable outside of the loop and then inside of the variable, those consider the same variable. If you identify a variable inside of a while loop and then you try to access it afterwards, Python will let you. And what we're utilizing right now and everything we're doing, because we're not using functions or classes just yet, everything we're utilizing is considered global scope for our application, so it can be accessed from anywhere. We're going to jump over the computer and test some of this stuff out and hope you can follow along. So let's try some of these sequences and loops out. We're just going to go through a couple simple loops and show you how they kind of work. So what I want to kind of do is let's start with x equals 5. All right. We'll show you how these if statements work as well. We can do that. Now say if x equals 5, we can print hello world. So we run that. We got hello world down here. It printed it out for us. We know we got in there. So now if we change x to 7 and run, now we will not get hello world. So what we could do is x input, please enter a number. And then what we could do, we've touched on this before, but those built-in functions to cast, we could do int and convert this into an integer as we bring it in. That way we can actually compare the x with the 5. So what we would do is run this, and we got to enter a number. I'm going to say 5. We put it in there. Now it says hello world. Okay, so that's cool. So what we want to do is actually loop this to see if we actually get this 5. I'm going to do a couple more things with the string just to make it look a little nicer for us. So I'm going to go ahead and do a while loop. We're going to go and do our while, and we're going to do is running, and we're going to tab this stuff over, just like we did in the if statement. Now we have a nested if statement. We have a while loop. Now we have an is running, but is running, if you notice, is underlined red. We don't have it assigned yet, so we need to create it outside of that scope. Is running equals true. This is our Boolean value. Now we can see that this works. So what I want to do is, if x equals 5, instead of doing print hello world, we can still print hello world. We can do print you guessed the right number. You guessed the right number. And what I'm going to do is set is running to false. Now remember, in our conditional, we use 2 equal sign to compare, and we only use 1 to assign. So if I run this, and it says please enter a number, and I do 5, it'll end. But if I do 7, it says please enter a number, 8, 9. And it's going to keep repeating over and over and over. And that's kind of what we want. As soon as I hit 5, though, it says you guessed the right number. And we're done. Easy stuff, right? So now let's think about something else. Let's do this. We can say my string. Let's do that my string real quick. We'll do my string equals ABC. We'll see plus 1, 2, 3 plus XYZ. And what we can do is now do our for character. Let's just do C for character in my string. We can do print C, and what will happen is it should go and print ABC 1, 2, 3 XYZ in a straight vertical line. So please enter a number. We need to make sure we guess this first. We gotta get 5. You guess the right number, and as we can see right there, our output is ABC 1, 2, 3 XYZ. Straightforward. Hope that helped you guys. I hope you learned a little bit of stuff. Hope you're having fun with this flow control and actually be able to get some cool things happening in your Python applications. And remember, if you have questions, concerns, anything you need to know, jump in the Discord, ask us some questions, and we'll be happy to answer.